Okay, so this is just the heads up on the activity of siphoning. So this is an activity that you're going to be doing that will really feed into the work we're doing in class on rates, in particular flow rates. Okay, so this is how it works. You have a container of water. Okay, so this is a way of getting water out of a container without using a pump, without using anything mechanical even. Okay, you just have to have the container of water at a higher level than where you want to send it. So essentially you've got a container of water like this, and then you have a pipe that kind of sits in like this. Okay, and what you've got to make sure is that the pipe is full of water. Okay, so if you've got water in the pipe, then that will work. The other thing you must have is a difference in level between the end of the pipe and the water level. Okay, technically the bigger this difference is, the better flow rate you'll have, but we'll talk about that in a minute. All right, so how does it actually work? But when you set it up like this, all this water here basically falls out. Okay, so gravity acts and this water here falls out due to gravity. All right, that's simple enough. But when it does that, it kind of pulls this bit along here. So the stuff up the top here, it gets pulled along because of suction. Okay, so due to suction, this stuff here gets pulled along. All right, and that happens all the way along. So essentially, because of the suction there, you've got this constant suction up in here. And so you've got water getting pulled in and then water being spat out down the bottom. That's basically how it works. So what are we going to be doing here? Well, I'm going to show you how to settle this up just with a tube and a bucket. But then once that's happening, we are going to focus on this business end of things here. And what's going to happen is you're going to measure the flow rate. Okay, so if you want to measure the flow rate, what you need to measure is two things. First of all, some time, a number of seconds. And secondly, the volume that's put out in that time. Okay, doesn't matter what the time is. Doesn't matter what the volume is, so long as you get them matching. Okay, so a certain volume put out for a certain time. Okay, from that, we are going to calculate the flow rate. Okay, and that is going to be measured in milliliters per second. But we also want to do more than this, okay? We want to actually practice a bit of unit conversion. So we want to get milliliters per hour, maybe liters per hour, maybe milliliters per second, okay? So that's our end goal. And of course, this depends primarily on two things. Number one would be the diameter of the tube, and secondly, the height difference. What I mean by height difference is this bit here, okay? But we're not going to be measuring that so much. We're going to be recording the diameter and we're going to be recording time and volume, okay? So what's it actually look like once you've got this? All right, so let's pretend, okay? On your stopwatch, you might run it for 40 seconds, okay? It doesn't matter how long you run it for. If you want to run for 30 seconds, 50 seconds, a whole minute, whatever, okay? So long as you've got a time, and then you measure the volume that is siphoned. So let's say in that time, just for argument's sake, you get 120 milliliters. All right, so how do we do the maths? Well, the flow rate is the volume divided by the time. So that's 120 divided by 40. So in this case, that's going to be 3 milliliters per second. Okay. That's how the maths rolls. You can then get that and convert it to milliliters per minute, milliliters per hour, liters per hour. You can even go days, weeks if you wanted to. Okay, so that's where this is heading. Now there'll be a worksheet with this, and I will show you how to set up the whole bucket and tube system.